So basically, when you talk about the combination of functions, you're just performing arithmetic operations. So you're performing arithmetic operations. So in other words, I'm going to give you two functions, f of x and g of x. I'm going to give you two functions. And they're going to be, and for us, they're going to be polynomial functions. They'll both be polynomial functions for us. And what you're going to do to those functions is this. You're going to add them together. You're going to subtract. That's what we mean by arithmetic functions. Arithmetic. So you're going to add, you're going to subtract. What are the two other arithmetic operations that you've done? Multiplied and what else? Divide. Okay? But there's some notation that you need to be aware of. And here's the notation how it's going to look for the most part. So one function will be called f of x, the other will be called g of x or h of x, whatever it is, whatever your function is called. The notation, though, is important. So if you see something like this, if you see in parentheses f plus g, now listen to the words. This says I'm adding two functions f and g at x. Adding two functions at x. Now, don't confuse that with multiplication. This does not mean f plus g times x, okay? That's not multiplication here. You're adding two functions and you're evaluating it at x. That's what that is. At x, not times. So that's not multiplication. The definition, the way it's written, here's the definition. This means this. F of x plus g of x. F of x plus g of x. So f plus g in parentheses at x means what? F of x plus g of x. Okay? Number one. Here's number two. F minus g at x. F minus g at x. Using that same idea, what do you think that could be written as? F of x minus g of x. That's what that is. Good. So whatever's listed first goes first. F of x minus g of x. Okay? Number three. F times g at x. How else can I write that? F of x times g of x. All right. And then number four, f divided by g at x. How else can I write that? F of x divided by g of x. So it's just a matter of removing the parentheses, f plus g here, removing the parentheses here, removing the parentheses here, removing the parentheses here. It's just knowing how to write this because that'd be important in a little while. Okay? All right, now let's review something before we look at these. Let's kind of review something first. All right, suppose that f of x is 2x squared minus 7x, just that, 2x squared minus 7x. And I want to find, you had this on a previous test, and you had this last semester as well, this review. Suppose you want to find number one, suppose you want to find f of negative 3. What did you do to find f of negative 3? Wherever you saw the variable x, you plugged in what? Negative 3. That's what you did. So you said, well, that's going to be 2 times negative 3 squared minus 7 times negative 3, right? Wherever you saw the variable x, that's what you substituted. And then you use the order of operations. Now, some of you are doing this based on that first test, I think. or I think I may have had it on the second test as well. But you're doing this. You're saying 2 times a negative 3 first. Can you do that? No, you got to do the order of operations. The order of operations says you do the exponent first, and then you multiply. So what's negative 3 squared? 9. 9 times 2 is 18. Okay, so that's 18. Now what's negative 7 times negative 3? Positive 21. So what's f of negative 3? 39. Okay. Number 2. Suppose I want to find 5 times f of 2. 5 times f of 2. That's what this says, 5 times f of 2. What do you think you have to find first? F of 2. You got to find f of 2 first. Whatever that is, then you multiply by what? 5. So let's find f of 2 first. So f of 2, the same thing. Wherever you see the variable x, what do you plug in? What do you plug in? 2. So 2 times 2 squared minus 7 times 2. What's 2 squared? 4 times 2? And what's negative 7 times 2? So what's 8 minus 14? Negative 6. All right, so that's f of 2, right? But what do I need to multiply that by? So that's 5 times negative 6, and so what's that equal to? Negative 30. Okay? So when you do the one in the worksheet, see where it says numbers, letters A and B? Now be careful. For letter A, which of these two functions are you going to use for letter A? F, the first one. For B, which one are you going to use? The one that says G, right? Okay, so those are two different ones. So you got to make sure you're using the correct one. All right, now let's talk about how to do these other ones right here. All right, and that's where this is going to come into play right here. Okay? All right, so that was a review for this part. Number 3 deals with the new stuff. Okay, number 3. Well, actually, let's go ahead and do 2 different functions. So let's do our functions different now. So let's suppose that f of x is negative 3x squared minus 5x plus 4, and g of x is 7x minus 1. So write those down. So that's f of x, and that's g of x. First of all, do y'all know that those are polynomial functions? Okay. So on your test Saturday, you need to be able to do something like this. Find each of the following. Okay, number 1. Find, in parentheses, f plus g at, let's say, negative 5. I'm sorry, let's say 2. F plus g at 2. Don't let that be difficult. You know how to rewrite this statement. How do you rewrite this statement using our definitions from right here? F plus g evaluated at 2 means the same thing as finding what? F of 2 plus g of 2. You find each one and then add them up. That's all that is. So let's find f of 2. So f of 2 says this. I go which function now? F. So I'm just going off to the side. I'm doing the work. I'm doing the work on the side. So I go to my function f, which is this quadratic function. And where we see the variable x, what I'll plug in? 2. So I get negative 3 times 2 squared minus 5 times 2 plus 4. Then using the order of operations, I'm going to square first. What's 2 squared?
4.
And what's 4 times negative 3? Negative 12, and then that's going to be minus 10, right? Plus 4. So what's a negative 12 and a negative 10?
Negative 22.
And what's a negative 22 plus 4?
Negative 18.
Negative 18. Now remember, all you found was which part of my problem? F of 2. So notice I'm right under this, I'm putting negative 18, right? Now what is I got to find? G of 2. So now we've got to find g of 2. So g of 2, Now to find g of 2, which function do I go to? G. So g of 2, you're going to say 7 times what? 2 minus 1. And what's 7 times 2? And what's 14 minus 1? 13. So that becomes negative 18 plus 13. So therefore the on the test or the worksheet is going to say f plus g at 2 equals blank. So what's going to go in that blank? Negative 5. Very good. Negative 5. That's all you did. Okay, let's do another one. We're going to take a break in a little while. Let's do another one. Number 2. Okay, now remember, we talked about this in the past. I want you to think about something. Addition is commutative, right? Y'all agree? In other words, 3 plus 6 is the same thing as saying what? 6 plus 3. So I'm asking you this. We found f plus g at 2 to be what value? Negative 5. So I'm going to ask you this now. All right, well, let's suppose I asked you, then what is g plus f at 2? But the question is, if you found number 1, you think number 2 is going to be different? No. Because number 2 in your mind, it's still saying g of 2 plus what? F of 2. Well, f plus g at 2 is f of 2 plus g of 2. Well, isn't that the same thing as saying g of 2 plus f of 2? Yeah, so addition is commutative. So basically what I'm saying is that on the worksheet, if it says f plus g at 2, it's not. But if it did, f plus g at 2, you found the value. And then all of a sudden it says g plus f at 2. Don't do the work all over again. Because you know addition is commutative. The order in which you add does not matter. What's this answer going to be? Negative 5. Okay? Number 3. Suppose I want to find f minus. So now we know how to add, right? Let's talk about subtracting now. F minus g at negative 3. F minus g at negative 3. All right. By definition, how are you going to rewrite this? F of negative 3 minus what? G of negative 3. Y'all agree?
Yes.
Okay, what is I got to find first? F of negative 3. So let's do that. F of negative 3. So remember your function f was negative 3x squared minus 5x plus 4. So wherever we see the variable x, what are you going to substitute? Negative 3. So do y'all agree you're going to get negative 3 times negative 3 squared minus 5 times what? Negative 3, and then plus what? 4. Order of operations. What's negative 3 squared? What's 9 times negative 3? Negative 27, good. What's negative 5 times negative 3? Plus 15, and then plus 4. Y'all agree? Okay. All I have left is addition, but remember you got to do it from left to right. So what's negative 27 plus 15? Negative 12. And what's negative 12 plus 4? Negative 8. So this right here is negative 8, right? You agree?
Yes.
Okay. Minus. Now we got to find g of negative 3. So let's find g of negative 3. Okay, g of negative 3. Now this time, remember, I got to go to which function this time? G. So g was that linear function, 7x minus 1. So you're going to say 7 times what? Negative 3 minus 1. So that's negative 21. Subtract 1, which gives me negative 22. So now I have this. I have negative 8 subtract a what? Negative 22. Now remember though, you're subtracting a negative number, right? So that really becomes in your mind, if you remember from a previous course, that really becomes negative 8 plus a what? 22, which gives you 14, is that correct? You agree it's 14?
Yeah.
All right, so in the blank is going to say this. F minus G at negative 3 equals blank. What goes in the blank? 14. Okay? Don't make it difficult. Each little part you've had previously, it's just a matter of you connecting those two now. Let's do one more and then we'll take a break and we'll come back and we'll do some multiplications and division with these. But one more. Here's what I want to ask you. Number 4. All right. Suppose I had this. G minus F at negative 3 equals blank. G minus F at negative 3. Well, I'm going to ask you this. If F minus G at negative 3 was equal to 14, right? Is that going to be 14 here?
Yes.
No. Because subtraction is not commutative. You remember that? Is 7 minus 3 the same as 3 minus 7?
No.
No, it's not. What's 7 minus 3? 4. What's 3 minus 7? Negative 4. It is not commutative. The only two arithmetic operations that are commutative, remember, is addition and what's the other one? Multiplication. Very good. 2 times 3 is the same as what? 3 times 2. So that's not going to be 14. That's not going to be negative 14, right? So you actually have to do the work. So let's think about this real quick. By definition, what's that equal to? Minus f of negative 3. But we already did g of negative 3. What was g of negative 3? We found it. What was it? It was negative 22, right? Y'all remember that? Okay. Minus, what is f of negative 3? Negative 8. Y'all agree? So negative 22 plus 8 gives me what? Negative 14. And it kind of made sense if you think about it based on what we just talked about. 7 minus 3 is what? 4, right? And so 3 minus 7 being what? Negative 4. Those are opposites, right? So if I say f of negative 3 subtract g of negative 3 is 14, and I go the opposite way, g of negative 3 subtract f of negative 3, what should that be? Negative 14. Okay? All right. So okay, so for number 5, let's go ahead and do a multiplication. So the pattern's the same. You added, you learned how to subtract these. Now let's look at multiplying these. Suppose that for multiplication I had g times f at 4. G times f evaluated at 4. By definition, what is that the same as? G of 4 times f of 4. So based on what we've been doing, what's the first thing I've got to find now? G of 4. Now remember your function for g was this. It was 7x minus 1. So g of 4, I'm going to go off to the side here. G of 4 is going to be 7 times what? 4 minus 1. So that's 28 minus 1, which is 27. Okay, so that's g of 4, so that's 27. Times, and then f of 4. Now we've got to find f of 4. So f of 4, you got to go to your function f. That was that quadratic function. So that's going to be negative 3 times 4 squared minus 5 times 4 plus 4. Go back to your quadratic function. Okay? All right, so 4 squared 16. 16 times a negative 3 is a negative 48. And the negative 5 times 4 is a negative 20, and then plus 4. So that's negative 68 plus 4. Remember, you add and subtract from left to right. So do the subtraction first,
Negative 56.
and then, huh? So
68,
negative
I'm sorry.
68, okay. So that's negative 64?
Yep.
Okay. Now that's what this is, right? Now use your calculator, so now tell me what 27 times negative 64 is. I don't have my calculator with me. Would you get a negative what? Just tell me the digits one by one. 1728? Okay. So 1728. So you would say G times F at 4 is equal to what value? Negative 1,728. Okay? All right, well, guys, if G times F evaluated at 4 is this, then out of curiosity, can you tell me what F times G evaluated at 4 is? The same thing, right? The same thing, because multiplication is commutative. And it kind of makes sense because even if you didn't know that multiplication was commutative, by definition, that would be F of 4 times what? G of 4. Well, you already found F of 4. What's F of 4? Negative 64. You already found G of 4. What's G of 4? 27. Isn't that product the same thing? Okay. Number 7. Now we're going to do division. Same idea. Okay, so for division, let's suppose we want to find F divided by G at 1. F divided by G at 1. By definition, what does that equal? F of 1 divided by G of 1. So I go off and I figure out what F of 1 is. So let's see what F of 1 is. So I got to go to my function F. And remember, your function F is this quadratic function that we let F of x be. So we see the variable x, what I'll plug in? 1. So I get negative 3 times 1 squared minus 5 times 1 plus 4. Well, what is 1 squared? And what's 1 times negative 3? What's negative 5 times 1? And then plus 4, right? Order of operations. So you got to add and subtract from left to right. Negative 3 to negative 5 is a negative 8. Negative 8 plus 4 is negative 4. So that's your numerator, right? Okay, let's talk about the denominator. Let's find G of 1 this time. So G of 1, then, remember, you got to go to your function G. That was a linear function. 7x minus 1. So that's 7 times 1 minus 1. 7 minus 1, which is 6, right? So you get negative 4, 6, which reduced is what? Negative 2/3. Okay? All right, well, if F divided by G evaluated at 1 is this, then can you tell me number 8? Can you tell me what you think F divided by G evaluated at 1 is? Is it going to be the same answer? No, because remember, division is not commutative. The only operations that are commutative is addition and multiplication. But if you know what F divided by G evaluated at 1 is, then you already know what G divided by F at 1 is. It's just the, no, you don't mean opposite, you mean reciprocal though, right? Reciprocal. So it'll be 3 divided by negative 2. Okay? All right, so that was that worksheet. Y'all should be able to be okay with that. That was that one. Okay?